So time to continue with our bit manipulation playlist. But before that, hey, welcome back to the channel. I hope you guys are doing extremely well. So the problem that we will be solving today is single number part 3. Now the part 1 and part 2 have been solved in the previous videos. In case you haven't seen them, go back and watch it. So what is the problem exactly stating? It is stating that you'll be given the nums array where every number will be occurring twice. Every number will be occurring twice. But there will be two distinct numbers that will be appearing once. Let me explain. So if you see 2, it is appearing twice. If you look at 7, it is appearing twice. If you look at 3, it is appearing twice. But there are two distinct numbers, which is 4 and 6. 4 and 6 are appearing once, and your task is to return 4 and 6 in any possible order. You can return 4, 6, you can return 6, 4, doesn't matter. And it is guaranteed that there are two distinct numbers that are appearing once. So if this problem comes up in an interview, the extreme name solution that I can think of is hashing, right? So can I hash the numbers and their frequency? Probably yes. So what I will do is, I will take a map data structure, right? And that will be storing the number and the frequency, where the number is the key and frequency is the value. We'll start iterating in the nums array, and the first number is 2. So I'll say 2, 1. After that, I'll move on to the next number. It'll be 4, 1. After that to the next, it is 2. So 2, 2. After that to the next number, it is 6. So 6, 1. After that to the next, 3, 1. After that to the next, 7, 1. After that to the next, 7, 2. After that to the next, 3, 2. Once you have completed the traversal, what you can do is, you can traverse again in the map, not in the array. You can traverse in the map, and this time, whichever keys have a value 1, whichever keys, because this is the key, and this is the value. Whichever keys have a value 1, those numbers will be the numbers that are appearing once. Very simple. So time to write down the pseudo code. In case you want the C++, Java, Python, JavaScript code, you can find them below. So what I'll do is, I'll take a map data structure. So map of integer as the key and integer as the value, because all the numbers are in the integer data type range. So after this, I'll traverse in the nums array, which is from I to n-1. I'll go into the map and I'll say nums of I ++. Very simple. If you're using Java, you can do a put, right? After this, what I can do is, I need an answer list, because I know that there are two numbers, and the function is expecting you to return a list of two numbers. The two numbers that are appearing once. So I'll take a list in C++ vector, in Java array list, in Python you can just keep it as the one that I have written. So after this, what I'll do is, I'll start traversing in the map. So assuming an iterator, again depending on programming languages, the iterator might vary. So I'll go through the map, and what I'll say is, okay, if it.value or it.second, so I'll write second, if it.second is 1, which means, yes, this number is appearing once. So I can say, okay, answer, can you probably add this number, which is it.first. Again, this is the first and second is in C++. If you're using Java or something else, key or value might be the 1. So done. So once you would have finished iterating, your answer would be storing, for this particular example, 4 and 6. So what you can do is, you can go ahead and return answer. So what will be the time complexity? Let's analyze. So this will be n logarithmic size of map, which is m. What will be this? Size of the map, bgo of m. Very simple. Again, I'm taking logarithmic of m because I'm assuming that the map is taking logarithmic. If you take something as an unordered map in C++, it might take bgo of 1. Again, depending on your programming language, time complexity of map might vary. So you can analyze according to that. So I can write the time complexity as n logarithmic m plus bgo of m, whereas the space complexity is bgo of m for storing all the elements in the map data structure. How many elements are there? So I'm saying all the elements are appearing twice, right? And there are 2 elements which are appearing once. So if I count 1, 2, 3, 4, 5, 6, 7, 8, and how many am I storing in the map? I'm storing 5 elements. So that's basically 8 by 2 plus 1. Near about that? Yes, because all the elements are appearing twice and there's one which is appearing once. So what I can say is the value of m is nothing but n by 2 plus 1. Super simple. Yeah, that's how easy it was. So obviously the interviewer will not be happy with this one because we are using an external data structure and he'll ask you to optimize it. So in order to optimize the brute force, I'll be using the concept of bitwise operators. Now to be very specific, I'll be using the concept of buckets. Yes, it's a simple one. So what I will do at first is, I'll take the XOR of all the numbers in the nums array. So if I take XOR of all the numbers in the nums array, what I'll have is 2 XOR 2 because 2 is appearing twice, 7 XOR 7 because 7 is appearing twice, 3 XOR 3 because 3 is appearing twice, and there's a 14 and there's a 4 and they're appearing once. So I'll take 14 and I'll take 4. Now what I'll do is I'll XOR everything. So if I XOR down everything, what will happen is 2 XOR 2 will be 0, 7 XOR 7 will be 0, 3 XOR 3 will be 0. I'll be left out with 14 XOR 4. Now 14 is 8, 4, 2, which is basically 1, 1, 0, and 4 is 4, so that's 1, 0, 0. If I take a XOR, so this will be 0, this will be 1, this will be 0, and there's a 0, so this will be 1. So this is what I will get. That's basically 8 plus 2, 10. So the XOR that I'll get is 10. If I ask you, this 10, what is this? This is nothing but XOR of 2 distinct numbers, which you're looking for, right? You're looking for these 2 numbers, and 10 is the XOR of these 2 distinct numbers. If you look at the XORs, like binary XOR, do you observe something? There would be a minimum of 1 bit which is different. There would be a minimum of 1 bit which is different. Over here there's a 1, there's a 0. So 1 bit is different. The second bit is like, there are 2 bits. There are 2 bits which are different in 14 and 4. Why is that? Because both of them are distinct numbers. So I'm very sure if there are 2 distinct numbers, which is already told to us in the question, I'll always have a minimum of 1 bit which is different in them. Now all the bits cannot be same because both of them are 2 distinct numbers. Minimum of 1 bit position will be different in them. Agreed? Keep that in mind. Keep that in mind. So what I'm saying is minimum of 1 bit index or bit position will be different. So the number is 10, which is 1, 1, or rather 1, 0, 1, 0. Now I know one thing. Because I did a XOR, I got 1 and 1 at the bit index which were different. So these 2 bit index were different in both of these numbers. In both of these numbers. I know it. Now the next step is to use the concept of buckets. Now for that what I'll do is, I'll either take this bit index or I'll either take this bit index. You can take either of them. It will be working fine. Now the easiest way is to get the rightmost bit. So I'll be taking the rightmost set bit. I'll be taking the rightmost set bit. How can I do it? Again, it's very, very simple. Do you remember one thing? I told you if the binary is something like 10101000, and if you write number minus 1, I've already told you this in my previous lecture. If you write num minus 1, what will happen is the rightmost bit will be turned to 0. Everything to the right of it will be turned to 1, and the left stays as it is. So this is the binary of number minus 1. So what you will do is, you will do an AND of it. You will do a AND of it. So when you do an AND, what you get is 0, 0, 0, 0, 1, 0, 1. So if you carefully observe, everything to the right of the rightmost bit was turned to zeros and the left was copied. Okay. And the next thing is very simple. You will take a XOR and you will do the XOR with the original number. So if you do this, what will happen is 1, 0, 1, 0, 1, 0, 0. This was the original number. So if you do a XOR, you'll get a 0, 0, 1, 0, 0, 0, 0. So what you did was, you basically got this number. So you basically got a number where the rightmost bit is turned on. And that is very simple. Initially you took the number, let's assume you took the number and then you said AND with number minus 1. Okay. After that you did a XOR with the original number. So if you do this, what you'll get is the rightmost bit and everything as zeros. The rightmost bit and everything else as zeros. Okay, so you know the concept now. So can I say, if I do this on this number which is 10, what I will get is 1, 0 and everything as 0. I'll get this number which is nothing but 2. So apply this operation and you will get it as 2. Now what is 2 signifying? You have the rightmost bit turned as 1. If I ask you a very simple question, 14, what is that? 1, 1, 1, 0. 4, what is that? 1, 0, 0. So 14 is this, 4 is this. Have a careful observation. This is the first bit from the right. This is the first bit from the right. So if I take two buckets, concept of buckets, if I take two buckets, can I say 14 will be in the first and 4 will be in the second, assuming the first bucket is storing all the first bit which are 1, all the first bit which are 1, and this is storing all the first bit which are 0. First, I was able to separate 14 and 4. I was at least able to separate 14 and 4 on the basis of first bit because that bit was different in each other. So because of this, 14 would go here and 4 would go here. I was able to separate them into two different buckets. Very simple. Very, very simple. Okay. I'll not get into the buckets, but I hope you've understood how do I separate them into two buckets. On that, on the first bit, I'll be separating them into two buckets. Fine. So let's take bucket 1 and let's take bucket 2. And now let's start traversing. What is 2? 2 is 1, 0. If I write 2, that's basically 1, 0. First bit is turned 1. So I can say this will be having everything which is turned 1 and this will be having everything which is turned 0. So the first bit is turned 1. So it will go into the bucket 1. Next number is 4. What is 4? 1, 0, 0. The first bit is 0. So it will go to the bucket 2. Next is 2. Now I know one thing. It will always go into the same bucket to which the previous 2 went. Okay. Next, 14. What is 14? 1, 1, 1, 0. Turned 1. So 14 will be there. Right? Next is 3. What is 3? 1 and 1. Turned 1. Next is 7. How much is that? 1, 1, 1. We'll go over here. Next is 7. 1, 1, 1. So it'll again go here. Next is 3. It will again go here. Now the beauty is, I know one thing. 14 and 4 will definitely go to bucket 1 and bucket 2 separately. They'll not be in the same bucket. and all the other numbers like 2, they're appearing twice. So either they will go to bucket 1, both of them will go to bucket 2. They cannot go to different buckets. So eventually, at the end of the traversal, you will see this, that the bucket 1 is only having one number which is appearing once, and all the other numbers are appearing twice. All the other numbers are appearing twice. If bucket 2 had more numbers, just imagine for that reason you had something as 8. Just for an example. Instead, let's take instead of 3. If I would take, give me a second, yeah. Instead of 3, I'll take 8. In that case, what will happen is 8 instead of going here will go here. But both of the 8 will go into one bucket. So if I do a XOR, since all these numbers are appearing twice, they'll cancel off each other. So if you do XOR of all the numbers in bucket 2, you'll get 4. Because all the other numbers that would be in bucket 2 would get cancelled. Same with bucket 1. 2 and 2 would get cancelled. XOR of 2 same numbers are 0. 7 and 7 would get cancelled. 3 and 3 would get cancelled. So eventually the XOR will be 14. So anything that gets to bucket 1, when you do a XOR, at the end, it'll have that one element. Because all the other numbers are twice. Very, very simple. Very, very simple. So the bucket was taken so that we could differentiate 14 and 4 into 2 different. Once you have done it, you know all the other numbers will always come in pair. So they could XOR themselves and they'll be 0. Got it? Okay, time to write down the code. Now you might be thinking, oh goodness, the code is going to be super tough. No, it's very, very simple. One thing, you don't have to take a bucket. Like, you don't have to take a data structure. I'm just taking the numbers. And at the end, I'm doing a XOR. So while taking the numbers, instead of storing them into a bucket, XOR them as you move. Na? Pretty simple, right? So something like, give me a second. Yeah, 2. So I'll go into bucket 1. So bucket 1, 2, XOR. Something like 4 will go to bucket 2. So bucket 2, 4, XOR. Something like 2 will go to bucket 1. Something like 14 will go to bucket 1. Something like 3 will go to bucket 1. Something like 7 will go to bucket 1. Something like 7 will go to bucket 1. Something like 3 will go to bucket 1. So eventually 2 and 2 will go off. 3 and 3 will go off. 7 and 7 will go off. And you will be left out with 14. So instead of taking an external data structure, an integer variable will work. So let's quickly write down the code. It's going to be super simple. Initially, I'll take the XOR of all numbers. So that's basically traversing from 0 to n minus 1. And I can say XOR equal to XOR of nums of I. So this will be XORing down all the numbers in the nums array. Once that is done, I need a number so that the rightmost bit is turned 1. Got it? So that can be used to differentiate between 14 and 4. Because I know there is one bit which is different. So what I'll do is I'll say, okay, let's take that number rightmost, something like this. And you know the formula. It's XOR and XOR minus 1. And then an AND with the original number XOR. So what this will do is this will give you a number which has the rightmost bit set as 1. Now why did I take it? I took it for a very simple reason. I'll explain you. So I'll take bucket 1, I'll take bucket 2. So initially bucket 1 is 0, bucket 2 is 0. I'll start traversing for I equal to 0 till n minus 1. I'll start traversing in every number. So what was the initial number? 2, right? Now for 2, I want to check what is 2. 1, 0. I want to check if the rightmost or the first bit is set or not. Because on that basis, I'll put them into bucket 1 or into bucket 2. How do I know it? Yes, from this rightmost. What is the rightmost number? 1, 0. So if you do AND with it, if this bit is set, it will give you 1 and then probably something. So it will be a non-zero number. If you take something like 4, which is 100, and if you do an AND with the rightmost bit, what you will get is 000. So this way you can figure out if the first bit on the right, if that's set or not. That's why I figured out the rightmost bit. Got it? You just have to differentiate from one bit, because the main agenda is to make sure 14 and 4 gets into two different buckets. That's the main agenda. Perfect. So what do I write? So I write if, what's the number? Nums of I and the rightmost. Now if this is a non-zero number, it means it is in bucket 1. So bucket 1, please hold it, which means take a XOR with it. Nums of I. And or else I said bucket 2 equal to bucket 2 nums of I. So at the end of the day, I know bucket 1 will be the number itself, because all of the other will be in pairs and they'll cancel off each other. Same with bucket 2. So what I can do is I can go ahead and say return. I need a list. So B1 and B2. Again, the order doesn't matter. So you can straight away return B1, B2. So what is the time complexity? So the time complexity, okay, let's analyze. This is bgo of n. This is bgo of 1 because it is bitwise operations. This is bgo of n because all the inside operations are bgo of 1. So I can say that the time complexity is bgo of 2n. And I can say that the space complexity is bgo of, how much will it be? Bgo of 1. Because I'm not taking data structures, I'm taking variables, which is doing XOR on the go. Okay, so there is a catch. If you submit this code, it might give you a wrong answer. Why? So let's see this. So there is something as XOR minus 1. Now what is the lowest possible number that an integer can store? That's minus 2 to the power 31, and the highest is 2 to the power 31 minus 1. I've already explained it why in the previous videos. Go back and watch it. So it's minus 2 to the power 31. So imagine if the XOR comes out to be minus 2 to the power 31. Imagine if I give you an example like 1, 1, 0, minus 2 to the power 31. Imagine this is your nums array. And if you do a XOR, the XOR will be this, because 1 and 1 will get cancelled, 0 will get cancelled, and you'll have minus 2 to the power 31. So if you apply this formula, what will happen is, you'll say XOR, which is this, and with, my bad, let me erase, and with XOR minus 1, which is minus 2 to the power 31 minus 1. So this is something that an integer variable cannot store. There's something that an integer variable cannot store. If the XOR comes out to be the smallest number, and if you do a minus 1, that cannot be stored in an integer data type. It will overflow. So make sure you take a long for this XOR. If you are going for an interview, specify this. This will be impressing the interview. So I hope you've understood the time complexity, the space complexity, and this optimized approach. So I hope you've understood everything. And if that is the case, please do consider giving us a like. And if you're new to our channel, please consider subscribing as well. With this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye. Take care.
Whenever your heart is broken.